Okay guys, so in this video I will give you an intro to post-processor modification. So as we saw together, the post-processor is a way to take what you designed in RoboDK. So let's say your RoboDK simulation program and translate that to something that is a robot program for a given controller. Controller. And that for that to happen, we generally go through a translation phase using a designated post processor. So the goal is really to simply go from your simulation program to your robot program, and that goes through RoboDK post processor. So up until that point, I think that this is relatively clear. But this is just what happens on surface. Here is pretty much a kind of lockdown phase for people that are not, let's say, advanced in RoboDK. So for them, this is completely transparent. You go from there, you go right click, select processor, right click, generate program, and then you go from that step to that step and you're in VS Code. But in the background, there's kind of two steps here in the translation phase. So if I was to copy and paste that here, bring that here, Control C, Control V, bring that there. So here in the middle, there will be two steps in this translation phase. So the first step will be for RoboDK to create what I call a RoboDK generic code. So let's call that RoboDK generic language. Then there will be the post processor applied. So what happened is, like, no matter what robot you have here, no matter what post processor was selected here, no matter what anything here, you will go from simulation program and RoboDK will generate, even before it does anything with the post processor, it will regenerate a RoboDK generic language. This will always be generated in your temp file. So if you type temp %temp in a file explorer, you will reach your temp file. That will create a program called post followed by progname .py. So it will always create a program like that. So we'll see those steps one by one afterwards. Then that program here, which is generally kind of a text file, if I can say, will be sent to the post processor for translation. So now this is where the translation will occur, and then this program will be transmitted to the user into the C user, C user, in this case Jeremy, and then file or documents, or my documents anyway, and then RoboDK. So this is the process. You need to understand very well this step if you want to be able to modify this step. Otherwise, it doesn't make any sense. So let's start by creating a very simple program. I will go ahead and open the first ever station we played with. Oops, this is the videos. I'm not looking for the videos, I'm looking for the files. That here, we'll go for training module, module 1, environment, rectangle. So this one is a KUKA robot. We'll just recreate real quick our station. So I bring that here. I'm gonna create a first point somewhere here, second point here, third point here, fourth point here, and then create program. Perfect. So I have a basic program like that. I'm gonna give it a name so that we can really differentiate from one program to the other. So let's call that F2 KUKA post modif post. So very specific program name. Right click, select post processor, KUKA KRC2 in this case, could have been a KUKA KRC4 depending. Right click, generate robot program, and that will bring up KUKA modif post.src, and the .src or .source file come in with the normal header, generic header, followed by the first mode, followed by the base definition, followed by the tool definition, followed by the program. So to reach that point, so this is the last step of this series here. So if I was to kind of make that smaller, or anyway, very small. So RoboDK is here, this is here. Now we need to figure out like the two steps in between. If we open a file explorer, any file explorer, create a new one, and you go ahead and you type %temp %, doesn't matter if you enter the caps or not, you will find in your temp folder a post KUKA modif post. So as you can see here, it's the same name as this one here, same name as the one we gave to RoboDK here, but with a post written before. So like I said, here it will be post program name.py. We can open that py file in our text editor, VS Codium. So I can bring that here, and I'm gonna split that to the side, so split left. I want to have this here and not to have this here. Perfect. So step by step here, we still have one step missing. But step by step here, we went from having this program in the UI to RoboDK generating that .python file here. So that Python file here. In this Python file, you will find a few things. First, some import that you don't care much about. It will give you the path to where you should find the post processor. Here, it will tell what post processor you selected. So this is whatever post processor we selected here will appear. Then there's a small section that we don't care about whatsoever. In fact, we do, but you don't for now. And then you have the program. So the program will always go as follows. So you will have a R prog start with the name of the program, so KUKA modif post. You will have a first run message where it just says program generated by RoboDK, the version number for a specific robot on a certain date. All of that here. Then it will say, okay, it's using either nominal or calibrated kinematics. Then the program will start. And you will have all the section of that program here listed line by line. So here you have your set frame. So here you have R set frame. So R is for RoboDK, or in fact it's for your post. So you have set frame, and here we have the value of that frame. So here I'm not using my frame tool that I created, I'm using the robot base, so I can just remove that frame. Then you have your set tool. So it's using the tool named pencil, and the values of the tool, if I was to double click on the tool here, 82, 0, 101, 82, 0, 101 are there. 0, 60, 0. Then you start with the different movement. So you will first have a move J. So move J, then the position in you will have the Cartesian position followed by the joint values. So if we were to go to target 1, press F3, bring that to the side here. I'm going to bring it back. Wait a second. I need to put it, let's say, here. Bring that back. Move that to the side a bit. So you can see we have the position. So 500, minus 70, 632, minus 180, 30, 180. And then you have the robot joints. 10, minus 96, minus 119. You have 25, and then you have 23. So that's the first thing. So the information are transferred that way. Same goes for the move L. So here you have move L, P, 500, 246, 632, 180, 30, 180, and then the joint values. You will also have the configuration at the end here. So, but that's another story. And then when your pad is finished, you will have a prog finish and then a program save. So that goes back to that point. So RoboDK will kind of convert from conversion. There will be a conversion from the UI conversion to text.py, what is a text file. Then from that text file that we have, we need to apply a post processor. So the post processor by default will be hidden in, as we already saw together, C RoboDK posts. So this is where you will have all the posts. But to protect our interest a bit, all those post processors are compiled, so you can't really open them. If you were to take one of those, I don't know, I'll take because some of them are not unlocked because it's my version of RoboDK, so some of them are unlocked. Okay, so if I was just to open, let's say, ABB Rapid RC5, or even the one that we used for this one, which is KUKA krc2.py. If I was to open that, you would see, okay, copyright, blah, blah, blah. This file loads the compiled version of RoboDK post processor for the KUKA krc2 robot controller. More information, blah, blah, blah. Then you have detect Python version and post processor, so just detecting some stuff. And then it sends me back to a version of the post that is available and compiled here in V38, if I'm not mistaken. And then that will go to that KUKA krc2 version here. And if I was to bring that here, this is a compiled version, and even if you try to display that, it will be a whole lot of weird characters that are not very useful in that case. So that's just because we do lock access to the processor, because before we didn't do that, before everything was open. But that means that anyone that was just downloading a trial version of RoboDK could have access to all of our post processor, and that's kind of where part of our IP is. So you might understand that we want to protect that. So we're already 15 minutes in, so I will cut that one short. And in the next video, we will see what the post-processor looks like and how we can potentially do some basic modifications to it.